Question 19. We have an integral that we need to evaluate here, and we were going to use L'Hopital's rule, so we need to be able to differentiate that integral. And to do that, we're going to use the fundamental theorem of calculus. And essentially, the fundamental theorem of calculus says that if we have some function, the integral of a function, and we differentiate it, we generate that function. Okay, so that's kind of the rough idea of fundamental theorem of calculus. So for this one here, we're going to first of all check for our condition for L'Hopital's. If we have L'Hopital's, we can differentiate. So when I anti-differentiate or integrate this, I plug in the 0, and the area under a curve from 0 to 0 is going to be, for any curve, it's going to be 0, and that's going to be 0 in the denominator. So I have my 0 over 0. Okay, so that integral just has an area of 0, and in fact, any integral, if we integrate from the same point, we're just integrating a line, which gives us an area of 0. So we have our condition to be able to apply L'Hopital's, and this is where we're going to use our derivative of the integral and use the fundamental theorem of calculus. So I end up with the limit as x goes to 0 from the positive side. The derivative of that integral is just going to be sine of x squared. And then I end up with 3x squared as the derivative of the denominator. And when I plug in and evaluate this, I get 0 over 0. Now, it doesn't solve my limit, but I have the condition to apply L'Hopital's again, so I'm going to do that. So I'm going to apply L'Hopital's one more time. So I end up with limit as x goes to 0. This becomes the cosine of x squared. We use chain rule, so multiply that by 2x. I end up with 6x in the denominator. We can simplify this expression. Those x's cancel out. And so I end up with, this is going to end up being cosine of x squared over 3. And when I substitute in 0, cosine of 0 is 1. So there's my limit. So the limit of this expression is going to be equal to 1 over 3.